Hello, here are some experiments to explain the problem of ground loopings and audio hum. So, to demonstrate, we need first of all a microphone. This little box represents the microphone. Actually, it's a signal injector, so it can send out a signal and represents my microphone. It sends out signals of some millivolts, so not so high. I use this old box because it's working on batteries, so this is to avoid extra ground loops. We also need an amplifier or receiver, can be a camera, but this is the receiver of my signal. So in this case it's a signal tracer which has an input and it can make the audio hearable thanks to the little speaker. So let's say this is my microphone and this is my amplifier receiver. It can be the audio input of a camera or whatever, and I'm gonna connect both with an asymmetrical connection. So in this case it's just a traditional phono plug cable or kinch or RCI plug. So I go from the output of the generator to the input of the tracer. I start the generator. I don't know if you can hear very well, but I have, let's say, an audio signal without the peep from the generator, without any, how can I say, hum. Now, practically, this unit, I will switch it off, this unit probably, so this is all battery operated, so it's working fine, but practically this unit probably will be grounded to the mains because it might have an external power supply, or there might be other connections like video lines or going to a next amplifier. Anyway, there is a big chance this unit is connected by some means to a ground somewhere in the system. Now this is still not a problem. It should still work without any noticeable hum, but now I connect. It might be also my microphone is an amplified one and it has some connection to the mains or to a ground by some power supply. So I will now also make an external grounding. So this is a second grounding to the microphone system. And if we switch on the amplifier now, I don't know if you can hear it, we get a huge hum. Soon as I remove this ground, the hum disappears. Hey guys, what is happening here? What is happening here? I just made a second grounding to the system and it starts to hum. Why? What is happening that we made a loop. Look, we go from here to here and then we continue by this wiring, this extra wiring. We make a big electric loop. It's all short circuit together, and any magnetic field going into the loop will induce a voltage in the loop, and since it's closed, some current will run, and because current will run, there will be a voltage drop on the outer shield of the cable, not on the inner, and that creates some voltage difference which results in hum. Actually, even I don't need the external ground. Even when I connect just by this way, so just extra grounding from there to there, I get this hum. As soon as I disconnect, the hum is gone. Can you hear? So I'm just going from ground to ground again by another wire and I get this hum. To make it more clear and to make it very audible, I have a coil here which 1 kilohertz is going through. So I just put it on my wire. If I put on, can you hear? By the way, I switch off my microphone now, so the beep you hear is not coming from the microphone but from this coil. As you can see, it is quite strong. As soon as I break my ground loop, this beep is almost gone. So the same thing is happening here. This coil induces this wire. There is not a big problem with that, but when I make a loop, this induction creates a current, which then creates a voltage drop on the outer shield. So it's really spectacular to see. And the only other cable is this one. One way to avoid that currents can go through the loop is breaking the loop, and the most known way to do this is putting an isolation transformer in our signal line. Then the current cannot go through the loop anymore, and this problem should be gone. I will insert an isolation transformator and do the same test again. Now the audio transformer is inserted in the asymmetrical connection. So this is a standard 2x600 ohm audio transformer, which automatically isolates any current going through this loop, but it does not change anything for the microphone connection to the amplifier. So that still works. But if now I make the ground loop connection again, as you can hear, there is no extra hum coming. So because the current it stopped here, there is no current going through this transformer, so the ground loop is broken. I also take back my coil with 1 kilohertz. I know you can hear something of this 1 kilohertz because my microphone in my system, where you can hear my voice, is also an inductive type, so it's a magnetic one. So this coil sends out so strongly that the microphone picks it up directly. But anyway, when I put it over the cable, there is no more impact on the loop, so it does not influence my audio channel quality anymore. If you wonder why I use this coil, it's just to make the experiment more clearly, because my loop is very small. In reality, ground loops will be much bigger and give much higher hums than I showed you here, and that's why to really demonstrate very well, I use this coil, which gives quite a realistic kind of field you can expect in the field. Thank you for watching.